Hello everyone. Welcome to lesson 2 on bearings. If you have not yet watched lesson 1, please to ensure that you go back to lesson 1, watch the season, and then you come on over to lesson 2. Lesson 1 was the foundation of bearings. Lesson 2 we will be looking at angle properties. So bearings is associated with angle properties, so we need to know these properties in order for us to solve the problems that are associated with bearings. So today you're going to come with me as we explore these angle properties. Look at my diagram and I'm going to be exploring with you a few of the angle properties that are very critical in understanding bearings. So you take note that I have 3 lines on my screen. And these 3 lines that are on my screen are representing the north lines. Remember, I said you need to have watched episode 1 or lesson 1 in order for you to be at lesson 2. Now, in bearings, you must know that if you're going to be traveling, you need a north line. The north line is our 0 point. It is going to tell us where to start. Remember that when we're measuring a bearing angle, we must begin on the north line. It's an angle, so we're moving in a circular motion and we're going to another place. So now, on my screen, I have 3 north lines. Now, notice I said we're going to be looking at properties of angles. And one of the first property is angles between parallel lines. Now, remember, I hope you remember what parallel lines are, but if you don't, let me just quickly give you a quick refresher. Parallel lines run in the same direction. They must be running in the same direction. So as long as it is that you have lines that are running north, all these lines will be parallel to each other. So we're going to focus on the north lines. When we're dealing with bearings, we're moving from one location to the next, right? So here I have location B, location C, and location D. Currently, the locations are not connected, so I cannot measure anything. So I'm going to first connect them to each other. So I'm connecting B to C. I could connect C to D, and then I could connect D back to A. So we're traveling to 3 different locations. Now, one of the most important properties of angles when it comes on to a bearing angle is the angles between north lines. And it is an angle property that says that angles between parallel lines, these angles are considered co-interior. I'm going to highlight those angles that we're talking about for you. What are these angles that we're talking about? The angle right here, this angle traveling from the north line to the line that would take me to C. So I'm at B. The bearing that we're looking at right now is the one that would have taken me to C from B. And I'm going to emphasize that point that I just used the word from. In bearings, the word from becomes very important to you. When I say from B, it means that the angle is being measured at B. So B is our starting point. Notice that I went in a clockwise direction when I'm measuring my bearing angle. Now I'm going to come over to this other north line here, and the angle property that we want to emphasize today is co-interior angles. Co-interior, notice I use the word interior, that it means it must be on the inside of the north lines. This line that connects them is called a transversal. So the line that connects them and form the 2 angles inside are these angles. They are co-interior. I'm going to label this one X, and I'm going to label the other one Y, so that when I speak of the angle, you can relate to what I'm talking about, right? So angle X and angle Y, what does the property say? And you are going to repeat this to yourself until you remember it, because as long as you're doing bearings, you need to remember that co-interior angles sum 180 degrees. And the word sum means that when I add them together, I should get 180 degrees. Now come with me again. Are these the only 2 north lines here? No. So if you look on this side, there are 2 other interior angles over here. So notice my transversal that connects C to D. What if I should take What if I should connect them as well? So let's go. If this angle here, and I'm going to also label the angle and give it another letter name, let's call this angle Z. Angle Z is starting on north line 2. This is north line 2. It goes and connects to the line that would take me to D. Now this angle is co-interior to the other angle down at D, and it must be inside because it says interior. So this angle here at D, and I'm going to call this one W, so that we can relate to the angles. So angle Z and angle W are also co-interior. They exist between two north lines that are connected by a transversal. Therefore, it means that Z and W would also add to 180 degree. So the sum of angle Z and angle W will always be 180 degrees. And I could even look further. Notice that angle D is connected to angle B. So the angles that are between the north lines. So note, I want you to note where I'm drawing this angle now. Starting on the north line and going to the line that takes me to D. Starting on the north line and going to the line that takes me to B. These two angles, and I'm going to give them letter names as well. Let's call this one P. And let's call this one Q. It therefore follows that angle P and angle Q would also sum 180 degrees. Now this angle property will be critical to you when you are doing bearings angles, because you're going to be using this feature to find unknown angles. So let's see if we can just quickly find something that will be unknown on this diagram. So let me take out some of those and let's look at this. What if I told you that angle X is 50 degrees? So angle X is 50 degrees, and the question asks, what then is the size of angle Y? Now I would say to myself, based on what I know about co-interior angles, that since X and Y should sum, the sum of them should be 180 degrees, and I already know what X is. What number will I add to 50 in order to give me 180? Now we could do the reverse of that. Take the 50 out of the 180. So we're subtracting 50 from 180, since the sum of the two angles should be 180 degrees. So taking out my 50 out of my 180 will leave me with 130 degrees, which therefore means that angle Y would be 180 degrees, right? So guess what? I'm going to leave you with a question, and you can put the solution to the question in the comments after you would have watched the video. Just go to the comment section and you're going to answer, what is the size of angle Z if I told you that angle W is 45 degrees? Would you be able to find the size of angle Z? So I'm going to be looking out in the comment section, what is the size of angle Z? What is the size of angle Z? Can you apply the co-interior property rule to find the size of angle Z? Check it out and let me know in the comment section. So that's one properties of angles that you must know when you're doing bearing angles. Now we're going to do property 2. Do you know that a complete revolution is 360 degrees? A complete revolution is 360 degrees. Let's check that out. What does that mean for me and my bearing angles, and how will that help me to find unknown angles? Let's check right here. What if I am told that angle Y is 100 degrees? So I know that angle Y is 100 degrees. And I'm just using now my angle property that I just learned about co-interior angles to know that if angle Y is 100, then angle X would have been 80 degrees. Now when I add them, I should get 180, so I can just double check to make sure, say yes, I got this. So these two angles add to 180. It further goes on to tell me that the bearing of D from C. So notice I'm using some terms that you must become familiar with. It tells me that the bearing of D from C. So I come up right here, so at C, and the angle would start on the north line and it comes around here. So they're talking about angle Z. If they tell me that the bearing of that for that is 150 degrees, so I put in that information right here. How does the angles around a point help me to find this angle here? You can think about it. While you're thinking about it, let me confirm what you're thinking. I know that you're thinking the correct answer, but let me just confirm what you're thinking. If angles around a point would form a full circle, then we should know that a full circle is 360 degrees. So let's analyze all of that. The circle is divided into three parts, and I never said three equal parts, it said three parts. So I say one angle around here, that's 100, one angle around there, that's 150, and I want to know this little angle in here. Since the entire circle is 360 and I know two of them already, I'll say, all right, what is the sum of the two that is already there? So I know that 100 plus 150 is 250. So over this side of the circle accounts for 250 degrees already. So what is this part? We're going to take out the 250 out of the 360 to see what is left. What is left is going to be the size of this angle there, since a complete circle is 360. So let's take that out. Let's take out 250 out of 360. And by now, I'm expecting you to have arrived at the solution, and you should get 110 degrees. So it therefore means that the angle that is inside the triangle right there is 110 degrees, and I can insert that on my diagram. So I'm utilizing my angle properties to find unknown angles when it comes on to my bearing diagrams. Let's go again. Now, remember that we just looked at the fact that the angle around a point, so it must be one point that all three angles here are around. They're all there at the same point, and the sum of that is 360 degrees. Now, reminding you also that not all angles are bearing angles. Therefore, the 110 degree here does not represent a bearing angle. It's an angle formed inside the triangle, yes. But remember that a bearing angle must begin on the north line. So, I know that the bearing of C from B. So starting at B, going to C, I would say the bearing of C from B. From B, that bearing would have been a 80 degree angle, because starting on the north line and coming to this line that would take me down to C, I'm seeing an 80 degree turn. Now, what if the question had asked, what is the bearing of B from C? Now, if I say from C, I must go over to C, because from tells me where to start. Now, I'm at C and I'm doing a bearing. I must start the angle on the north line. Remember, lesson 1 went over that. I start on the north line and I go in a clockwise direction. So I'm going clockwise, and I'm going to pay attention to the fact that it says the bearing of B. So I cannot stop here, even though this angle of 150 is a bearing angle. It's not representing the bearing angle I'm looking for, because that would have been the bearing for D. I would have stopped at D. I want to go all the way around until I get to B. Notice I'm going around this point right here. I'm turning around the point, and I go all the way around until I get to the line. So I'm meeting the road that will take me to D. And this road here, so is the one that would have taken me down to D. So I stop on that line. So the bearing of B from C would have been the 150 here plus another 110 turn. So I'm turning 150 first, and I continue my journey another 150. So I would need to add these two, the 150 plus the 110, which gives me 260. So the bearing of B from C would have been a 260 degrees turn that I would have needed to do in order to get that bearing. So reviewing the two properties that we just looked at. Angles between north lines. Because our north lines are parallel, the angles formed in between them are co-interior. So their sum, so angle X plus angle Y is 180 degrees. Angle Z plus angle W is 180 degrees. The angle Y, Z, and the 110 here should be 360 degrees. Now, these you will utilize these properties to answer the bearings questions. So let's look at a CXC question and how would we approach putting in the information on this diagram. All right. So this is a January 2025 past paper. Let's run through and see if we could have used what we just learned to insert the information on the diagram. All right. So two ports, ports E and port G, and we can see this on the diagram, port E. So it's like a shipping port. And or it could even, yeah, it's a shipping port based on the information here. So port E and port G are on level ground, so they are flat. So it's, even though the diagram would look like one is in the air, they are on flat ground, but their elevations are different from each other. They tell us that they are 224 kilometers apart. If you should form a string, take a string from E and connect it to G, that's the distance that you'd get. The bearing of E from G. So let's look at that now statement. The bearing of E from G. Let's think about where that north line should be if I say the bearing of E from G. So if you just remembered that we're going to start at G since it says from G. The bearing of E from G is 302 degrees. So we can put in that information because you just learned all of that. So let's put that in. Starting on the north line, going in a clockwise direction, turning my circle, turning, turning, turning. Do I stop here? It says the bearing of E from G. If I stop there, that would represent the bearing of F. So I'm going to continue to turn until I get to the line that takes me to E. Now, this is going to represent the bearing of E from G. And they have indicated that this angle that we just looked at is 300. Let me just put it on the outside for now, for emphasis. It's 302 degrees. That's the entire bearing angle there, 302 degrees. Let's continue. It says a ship is anchored at F. So these are the two ports, but there is a ship out at sea anchored at F. So it's out in the ocean, some distance away from G. So the ship is some distance away from G. We don't know the distance yet. But the ship is on a bearing of 208 degrees, 228 degrees. From where? It says a ship is anchored at F, some distance away from G. So we're looking at comparing F to G on a bearing of 228 degrees. So I'm going to come here and I'm going to show you. Whilst I'm going there, I expect you to start think about it. A bearing angle starts on the north line. It turns clockwise. I go around. Should I stop here? Yes. How do I know that? It says a ship is anchored at F, some distance away from G. So I'm going to F. This orange angle here is 228 degrees. 228 degrees. All right. All right. So I have in all of that. And it also tells us, based on the information, that angle EFG, notice that the angle is at F. Because if you get three letters to describe your angle, the middle letter tells us where the angle is formed. The end letters tells us where the lines are extended to or extended from. So this angle is 52 already given to us on the diagram. Now let's read the question. On the diagram above, insert the angle 228 degrees, the bearing of F from G. So we would have done that. The bearing of F from G. The word from tells you where the angle is formed. You are starting at G on a north line clockwise. Notice all those statements. At G, north line, clockwise. So I'm at G and identify my north line. I go clockwise to the line that takes me to F. And it's an angle, so I'm creating my circle, turning my circle all the way around. All right, one mark. It says determine the value of angle FEG. Where is that angle at? FEG. So the angle must be at E, coming from the two lines F and G. So the angle that we're looking for must be at E. The middle letter tells us where the angle is formed. So we want to know what is this angle here? And how can I use the angle properties that I just learned to find this angle here or any other angle property that I already know? So let's go. I know that the complete turn that took place around here, so this black line would have been 302 degrees. So if I went all the way around here, I would have completed 302. If I started the journey and stopped here, so it would have completed 228. What is the remaining journey right here? So if the full journey up to this point is 302 and I did part of the journey and did 228, are you thinking what would you have done to get the remaining angle inside? Let's see if we can highlight that angle. I want this angle right here. Now, if the entire journey around is around to here is 302, what are we doing? I know that you're thinking of the right thing. 302 take away, because that is a part of the journey. I'm going to take out the part that I would have completed already to see what part of the journey remains. So subtracting 302 from 228 from my 302, what are you getting? You should get 74 degrees. So the angle that we're looking at inside, angle that we're looking at here is 74 degrees. Now, why did I need to find this angle in order to find the angle that they're asking me for? Why would I need this angle to find the angle that they're asking me for? Now, the angle that they're asking me for is inside the triangle that was formed. So it's an internal angle in the triangle. What you should know, and I'm going to remind you, is that the sum of the three angles in any triangle, no matter the size or the shape, the sum of the three angles in any triangle sums 180 degrees at all times. So if it is that I know what this angle here is, then I would be able to find the unknown angle at E. So notice I used my angle property here about the fact that I know my bearing angles, I know where it starts, I know how to turn. I had completed part of the distance and I needed to know what was the other part. So I subtracted them from each other to find this angle. Now, to find angle E, I would now use my angle property about the sum of the angles in a triangle. We're going to be adding the 74 to the 52 since we know those two already and we have accounted for them. So we're adding our 52 and our 74 because we need that sum. We need this sum in order to find angle E. Now, I'm just going to remind you that the sum of the three angles in any triangle is 180 degrees. You should find that angle by now. The sum of the three angles in any triangle is 180 degrees. So we can subtract the 126 from the 180 to find out what angle remains that belongs to. What is the angle that remains that belongs to angle E? So you're subtracting 126 and you should get 54 degrees. For those who are wondering what just occurred here, I borrowed a 1. You can use your calculator. I borrowed a 1. 6 from 10, that leaves me with 4. 2 from 7, that leaves me with a 5. 1 from 1, that leaves me with 0. So it means that the angle here is also 50. It is 54 degrees. And that would have found the angle that I'm looking for. So sometimes the angle that you're looking for will require you to do a first or initial step before you can find the angle that you're looking for. You're required to do a step first before you can actually use that information to find the angle that you are searching for. But you're using your angle properties, and therefore you must know what is these properties. The sum of the angles in a triangle, let's review that. The sum of the angles in any triangle is 180 degrees. So if I add angle E, angle G, angle F, I should get 180 degrees. You can check that for yourselves on your calculators. The angles around us a point should be 360 degrees. So I'm leaving you with another information that I want you to post in the comments